There are two things about tangents that we're going to look at today. Remember that a tangent, excuse me, is a line or a segment that just barely goes by and touches a circle in one place. It's really hard to draw them, but BC would be a tangent. It touches at point B. So what we want to know, one of the things we want to know is when a tangent touches a circle, one of the things that happens is that the radius is perpendicular to it. So perpendicular means that they intersect at right angles. And so the radius and the tangent are always perpendicular to each other. Now that's important because what that creates for us is this right triangle right here. Whenever we have right triangles, it enables us to use Pythagorean theorem, special right triangles 30, 60, 90, and 45, 45, 90, or we can use trig to find out other things about the triangle or about the circle that we might need to know. And so in this picture then, tangent segments will be perpendicular to radius at the point of tangent, which means that radius AB is perpendicular to tangent BC. And that creates that right angle right there. Perpendicular means that they intersect at right angles. So if we look at these two problems here, notice how we have a tangent. We have a line that goes into the circle. That's going to be really important because of what we're fixing to talk about. I want you to notice the difference between the types of problems we have today. And then we also have this radius. Now, what we just learned is that the radius and the tangent are always perpendicular to each other, and so you can instantly go ahead and mark in that right angle. Now, once you see that, that tells us that we're going to be able to use this right triangle right here to solve some questions and answer some things. And so we want to find the value of x. Well, in order to find the value of x, I've got a right triangle, and since I have most of two sides, I think I'm probably going to need to use Pythagorean theorem, so let's check that out. Now, the problem with it is that we're missing this little piece right here. But if you notice, it is exactly the same length as the other radius. The radius doesn't change as it spins around a circle, and so we know that that piece is also 8. Which means that the entire side of that right triangle is 17. Now I have two sides of three sides of my right triangle, which enables me to use Pythagorean theorem. The legs A and B form the right angle, which means that 17 is C, your hypotenuse. So we have x squared plus 8 squared is equal to 17 squared. When you do the math, you get x squared plus 64 is equal to 289. Subtract 64 from both sides, you get x squared is equal to 225. And if you take the square root of both sides from that, we need to undo that square. We get that x, if x squared is 225, then x must be 15 because 15 squared is 225. And that makes sense. It's shorter than the hypotenuse. And so we have that the tangent is equal to 15. We can look at this second problem here. We have this radius that's 15. We have this tangent, JK. Usually it will say if it appears tangent, it is. It's really hard to draw it to make it look like it only crosses in one place. So usually if it appears to be tangent, then it is. So you've got your two legs, they form your right angle, which makes then your hypotenuse on your x. So you would have 15 squared plus 20 squared is equal to x squared. And if you do 15 squared is 225 plus 20 squared, which is 400, you get 625 is equal to x squared. If you take the square root of both sides to be able to solve for that equation, you get that x is 25. Now, both of those are Pythagorean triples. If you happen to remember your triples, we have a 3, 4, 5. We have a 5, 12, 13, an 8, 15, 17, and a 7, 24, 25. Number 2 is actually a 3, 4, 5 multiplied by 5. But if you don't remember your triples, no problem, just use Pythagorean theorem. So whenever you have a tangent and a radius, so you're always, in that kind of problem, you're always going to have one piece of the triangle come into the triangle. Now that's important because this next one is what we call the party hat theorem. It's a party hat because when you look at a party hat, it sits up on top of your head and it is the same height on both sides. It's not, you don't have a hat that's usually pointed with one side shorter than the other. And so it sits up there. And what we find out is that if you have two segments or two tangents that come from the same exterior point, in this case D, and they're tangent to a circle, then what we're going to know is that they are congruent. Those are congruent to each other. So AD is congruent to DB. So when you look at a problem like this, anytime you see, now notice the difference. Look at the difference between these two problems. Notice that in a tangent party hat, nothing comes into the picture. Neither of the two sides of the shape of the two tangents, they're both tangent. In a tangent segment where it's tangent to the radius, notice that one is tangent and one of those sides comes into and goes to the center of the circle. So always pay attention to what kind of situation you have so that you know how to work the problem. So when you set this up, we can see that these are both tangent. It's tangent at B and it's tangent at D. And so what that tells me is that BC and CD are the same length. That means that BC has to be 7. So the question is, what does X have to be so that that entire segment can equal 7? So X plus 3 has to be set equal to 7. Subtract 3 from both sides, and we can find out that if X is 4, both sides will be 7. We could do the same thing with number 4. Notice that again, we have two tangents. We've got our party hat sitting on the side, nice and equal. Okay, and so we know that those two pieces have to be equal to each other. The question is, what value of X makes that happen? So 3X minus 6 is equal to X plus 10. Let's do our algebra. Okay, that's the only geometry you need to know, is that those two sides are equal to each other. From there on, it's algebra. Subtract X from both sides, and you get 2X minus 6 is equal to 10. Add 6 to both sides, and you get 2X is equal to 16. Divide both sides by 2, and you get that X is equal to 8. If I had asked you for how long they were, if X is equal to 8, then QW is 18, and PW is also 18, because 3 times 8 is 24 minus 6 is 18. Now let's look at some more of these. These are a little more complicated because we have multiple party hats. And in this case, I think it's helpful for you to go in and kind of highlight your party hats in a different color so that you won't get them confused, because what happens is usually you want to start using the tangents and you don't pay attention to the party hat part. You'll want to combine them, like use a green and an orange together. So it says to find the value of X and the perimeter. So find a place to start. It doesn't matter where you start. I'm going to start right here with this 13. And so if that side is 13, I've got that blue party hat. That means this side is 13. Then I'm going to go along to my green party hat. So one side is 5, the other side is 5. My orange party hat would be 13 and 13. And my yellow party hat would be 5 and 5. And then it asks me to find the perimeter of each polygon. So one, we know that X is 13. You know that this side is 18, this side is 18, this side is 18, and this side is 18. Notice, y'all pay attention, look right here. See that 5 and that 13? Notice that it's not cut in half. They will not always be the same size. Okay, those sides, this just happens to be a rhombus, but you can tell in the next 4 problems, they're not going to usually, or next 3 problems, they're not going to usually be that way. So the perimeter would be 18 plus 18 plus 18 plus 18, which would be 72. Okay, so that would be the perimeter. So when you look at number 6, on number 6, you have to find a good place to start. So I've asked for the perimeter and I've asked for X. And so the problem is, here's X. Okay, X is this party hat right here. Well, we can't use the other side because we know the whole thing is 14, but we can't start with the whole thing. We have to start with a part. So I have this party hat down here, right? This one starts with 6. So look for your individual pieces. Now, I have individual pieces here with 18 and 18, but those don't help me get to where I need to go. So this is where I need to start with this 6, because with that purple party hat, that's 6 and that's 6. Well, now the whole thing is 13. This whole side is 13. And so I know then if I take 13 and I subtract 6, that's going to give me 7. So this piece is 7, which means this piece is 7. Now, it just so happens that because that side is 14, that this is also 7. So 14 minus 7 is 7. Now, it's not always going to do that, so don't make that correlation. It's not always going to cut it in half because the 13 didn't get cut in half. That means that x with that green party hat is 7. So we know that x is 7, and then it asks for the perimeter. So with the perimeter, I would have 18 times 2 plus 6 times 2 plus 7 times 2 plus another 7 times 2. So I have 36 plus 12 plus another 28, 14 and 14, and you get that the perimeter is 76 units. Okay, so highlight to keep to help keep your party hat straight. Okay, so the first thing it asks for is it asks for x, and then I also asked you to find the perimeter. So we need to find x. So here's what I'm looking for. So let's label its party hat. And in this case, it makes it easy because now we can see what to set it equal to. So whatever it is, CT has to be 18. So the question is, what does x have to be so that CT can be 18? Well, that means that x is equal to 6 because you divide both sides by 3. So x is 6. So we know that this is 18. Then we have 12. That means this side is 12 because we have this pink party hat. Then we need this one extra little piece so that we can finish finding the perimeter. So we need this piece and this piece. If we take 52 and subtract 18, we get 34. Which means this other green side of the party hat is also 34. So then your perimeter would be 34 times 2 plus 12 times 2 plus 18 times 2. You could also go ahead and use that whole 52. There's different ways that you could do it. You could do 52 plus 34 plus 12 plus 12. So you could do it that way too. You don't have to break it into these pieces. This is not the only way to find the perimeter. I just did it to be consistent. And you get that the perimeter is 128. Okay, so the last one, it says that quadrilateral SHOW is circumscribed. Let me back up for just a second. Circumscribed. Circum means around, scribed means written. So what that means is that this SHOW, that quadrilateral is drawn around the outside of the circle so that the circle is touching the sides. That's what circumscribed means. It says that WO, from here to here, WO is 14. It means the whole thing. HM, this little piece, is 4. SW, so this whole piece, is 11. And then ST is 5. And so the question is, what is the perimeter of that green polygon? So in order to do this, you have to pick a place to start, and it doesn't matter where. But so let me tell you, you could start with SI. So you could find SI, you could find IH, or you could find WT. You can start in any one of those places. It doesn't matter. Whichever one you see first. I'll start here at IH. IH is 4 because you have this party hat, HM and HI. Then I know that ST and SI, that has to be 5 because of that party hat. Then I need WT. So WT is going to come from 11 minus 5. That part plus part equals whole. So I'm going to take the whole and subtract the part. That gives me 6. So WT and WE have to both be 6. Well, if that EO is going to be 14 minus 6, so that's going to be 8. And then you have OE and OM, that's going to be 8. So now you have all of your pieces. And so if you take your party hats and you add all of your pieces together, this side, those two are 8, those two are 16, those two are 12, and those two are 10. So I have 10 plus 12 plus 16 plus 8. Now, again, I just combined my corners because it was easier. You could also, if you wanted to, you could also say, okay, that's 9 and that's 12. You already had 11 and 14 and you can add them. So however you want to do it, it doesn't matter. But either way, you get that the perimeter is 46 units. So we had two situations with tangents. We have two tangents that create a party hat where the tangents are equal to each other, and then you have a tangent, and the tangent is always perpendicular to the radius. Notice those two pictures and pay attention so that you can tell the difference of when you're supposed to use each situation, depending on the problem and what it looks like.